So we'll be doing Canadian Cyber Defense Challenge Session 2 presentation. And basically, the first slide has a little shortened URL to the presentation. So feel free to grab it, or who has a QR code reader, feel free just to scan an image in the bottom right corner, and it will bring you to the presentation if you feel that it will help you to follow better. And Greg, please be moderator, so whenever you start, I'll begin the presentation.
Okay, sounds good. I think most people are in, so I think we could probably start so that we can be done by 12:35, 12:40, somewhere in that range. I know TechVoc is working hard to get a microphone so that they can hear and join. I think most others are in and can hear. For those of you who have not muted their microphones, please do so during presentation. If you do have a question, feel free to type it in along the side in a text format, and I'll make sure that we can answer those questions at a later on in the presentation. Thank you.
All right, sounds great. So I'll take over from here, and Jared, please feel free to jump in anytime. And if you want me, I can help you with a sliding, if it makes any sense. So I'll just jump into it and begin. So basically, some of you might already know me. I'm Alexei Vasiluk, or for short, Ollie, just to simplify the communication. So currently I'm having a very long title name, but it simplifies down to also security architect, and I'm with Great West Life. And basically, I'm a person who likes to be challenged and who loves to challenge others with IT things. That's pretty much all about the Cyber Defense Challenge today. And also, I'm an event architect for CDC. And Jared, would you like to introduce yourself?
Sure, yeah, good afternoon, everyone. My name is Jared Bader. I'm the Infrastructure Services Manager at Merlin. I'm mostly a network nerd, so I design, I build, I try and intentionally break, and I secure networks. So, I'm a event architect for the CDC along with Alexei, and I'm occasionally on Twitter. So if you want to follow me, go right ahead.
All right, thank you, Jared. Our today's objectives, and our session is quite short, but we will try to guide you as much as we can in order to prepare you for incident handling. And basically, we'll talk about incident response phases. And Jared has prepared an awesome real-world example how the incident handling practices are applied. So, and then we will finish with question and answer.
So just to interject here, this will prep you for May 10th, the big CDC competition. So maybe Jared and Alexei, you can just mention or talk a little bit about the competition and what's going to be happening on May 10th.
Sure. Basically, all our sessions will give you a little clue. We won't give the details out. Let's put it this way. May 10th event will be heavily coupled with incident response activities. And there is a couple more sessions scheduled, so we will disclose a little bit more information and tools that you will be using. So please be tuned, and it might be quite interesting and useful to attend these sessions. Greg, do you want to hear a little more, or is it enough intrigue?
No, that's good. I just wanted to let everyone know that what they're watching now will help them on May 10th.
Absolutely. Okay, so let's jump into incident handling. Basically, incident handling, it's an action plan for dealing with misuse of computer or network resources. And action plan. So basically, One who tries to respond to the incident without a plan usually miserably fails. So that's why we want to be prepared. And uh, unfortunately, incidents sooner or later occurs to any organization. There is no 100% security, and probably not probably, most certainly, every security expert in the field will tell you that sooner or later some asset get compromised, and unfortunately or fortunately, depends on the perspective, we will be dealing with an incident. An incident is an adverse event in a system or network. So what really does it mean? So basically, when your system compromises, it's not just like, okay, system tries to tell you, oh, sorry, I'm sick, I can't come to work today. No, usually it's only part of a problem. Most often, we have a problem such as the system tries to, or adversary tries to use the system in their own interesting way, for example, to attack another systems and networks. So let's jump into incident response phases. So there are several phases. So preparation, identification, containment, eradication, recovery, lessons learned, and pretty much incident has a circular nature. So we will be always repeating these steps in order to be successful.
I don't know.
And sorry, David, please mute your mic. I have quite feedback.
Yeah, I'll be back.
Awesome, thank you. Okay, so let's jump to the next slide, and basically incident response phase 1 is preparation. As you may know, and here's a school analogy, homework is not just for sake of being a homework, it's basically to prepare you for class or as an outcome of class. So for incident response, preparation is also very important. So the main goal is to be ready to handle incidents. So by being ready, we will be talking about policies and why do you need policy? For example, some networks, and for example, right now we're using Skype session in order to facilitate this presentation. So policy will, for example, regulate is Skype allowed in the organization. Then, of course, we need people. We need trained people in order to respond to an incident and to streamline work and organize pretty much everything together and start working on the incident. Then we, of course, need software and hardware. So basically, we need some tools and some place to put these tools in order to address our incidents. Communication part is very important. Specifically, in a bigger organization, communication might be challenging, but no matter of the size of organization, communication is basically the path how the incident or actually when the incident occurs, what should you do? Who should you talk first? Who should be engaged in order to respond to the incident? And basically includes overall security posture of systems. And what it means, it's pretty much, of course, we're not setting up Microsoft Windows 2008 server or 2012 server, and without any further ado, after clicking couple next, we're just placing it on the network. We want to exercise our due diligence and due care, and pretty much that's why we're hardening the systems, that's why we're applying the patches. So after a preparation phase, basically, just give me 1 second. Identification. So we have secured our systems, we have policies in place, we have a very good and knowledgeable trained people who are overseeing the systems. But at the end of the day, as it was said before, the incident will occur sooner or later, no matter how secure we are. So we need to understand by identification if the incident has occurred and how we will do it. We actually will be looking for deviations from the normal patterns. And what is deviation? It's pretty much just let's just take an example. There is a number 10, and If this number goes up or down, that is deviation. So that's how we're looking from the security perspective. So there was 10 network flows every day to this server. So let's say it's very underutilized file server. There was always 10 connections. Seems to be quite a normal pattern. And then all of a sudden, connections count jumped to 1,000. That's a problem. That's a deviation. We probably should look into it a little bit farther. Then we will detect attempts to do harm. So, okay, are there, like, okay, there is a way more connections today. Why? Maybe there is a backup cycle or something else. So it's just a logical procedure to pretty much understanding, is your spike in the deviation somehow associated with the harm or security issue? And basically, of course, what we're looking into. It is impossible to look in every single system simultaneously. Basically, most of the attacks will come into the network from perimeter, and perimeter is pretty much, in most of the cases, means internet. So that would be first place to look. Then we will look into host perimeter. Actually, what's happening on the host level? Okay, we see this network communication going to the file server, and would like to know how it's going and why it's going, and if it's malicious. And then, of course, we will look into the system level, and that's where we actually go to the box and start looking into the logs. And again, tools, for example, for network perimeter monitoring and host perimeter can be IDS, which stands for Intrusion Detection Systems. Network IDS will call, obviously, Network Intrusion Detection System, and host perimeter can be served by Host Intrusion Detection System. So that's just a simple example. Next slide actually shows Alien Vault, and it's SIEM, and it stands for System Event and Incident Monitoring, or maybe I misplaced a couple names, but the point is, in order to successfully monitor your network, you will have some kind of centralized analytical platform that will help you to collect all the events that are happening and show you them as a summarized view that can be easily digestible by a human being. Because, for example, a very busy system, and I'll take an example of DNS resolver of very small ISP. If you try to watch logs in real time when they're scrolling through the screen, your eye won't catch anything. And when you stop the log scrolling, actually your video buffer is so overwhelmed that it takes not a minute, but 30 to 40 seconds to finish the output. So SIEM should help you to analyze logs more efficiently. So phase 3, containment. Okay, so we identified that the incident has occurred. We used our processes and policies and people to pretty much understand how we are identifying the incident. Now we know for sure that somebody tries to get in and exfiltrate our data, for example, from our file server. So what should we do? We should contain. But how do we contain the incident? The first intention of a lot of people will be, oh, let's just unplug the server or power it down. That might be not a smart move, because first of all, we are doing business. This server serves its purpose for pretty much allow users to do their day-to-day activities, and we just cannot just simply unplug it. It's very important to remember, we never unplug things. We just want to contain it. And by containment, what we can do pretty much configuration changes in order to stop further data destruction, exfiltration. For example, configuration change might be, again, we need to keep file server available. So let's say we have a firewall on the host, and there is a potential, oh no, let's not touch firewall right now, but for example, there is simple access list which provided by the file share. So what we do, we probably will prevent this malicious connection from coming into file server, just change configuration of the file server and allow access only to known good users. That would be example. Second example will be firewall. We have our firewalls. Let's do the same thing on the firewall. If we have no access to configuration on, or if there is no configurable icon like this. And of course, one other thing that we always like to do as a security professionals is to preserve evidences. And that's where comes our syslog. The most effective way to preserve evidences, of course, it's always point your local syslog to remote syslog or any kind of log collector. It might be SIEM. That's how we actually will know that our logs are not tampered with. Okay, so we contained. Then, of course, we need to eradicate the issue that we contained. So basically, we need to make sure, of course, again, like that we have everything preserved for our further analysis for forensics purposes. And now we need to pretty much remove all potential malicious content from the server. There is a couple ways, and we need to understand what our decisions as security experts are. We can, for example, restore from backups. And I'll give you a second to think about it. For example, our machine was compromised, and we restoring exactly same machine from a backup. What potential issues might be with it? And I'm not requiring a response. I'm just giving you a few seconds to think about it. I'm pretty sure that the problem with just restoring from a last known good backup would be that we will restore it. But are we replicating exactly the same vulnerability that was our entry vector? Probably yes, because it's just a backup copy. Another point might be, actually, there is an additional problem with that. Additional problem with that will be we're actually removing all our compensating controls if they were done in configuration of this machine. So we need to be very mindful of it. And another option would be a complete reimaging or reinstall of the system. It might be necessary because it depends how good our forensics capabilities are, but we might not be able to detect all potential malware that is residing on this particular server. So maybe a fresh reinstall and pretty much applying the latest security controls might help us. Again, with complete reinstall and backup restore, you should also understand that we will stop providing servers or services to our customers, and that might be a problem. So again, it all depends on the way how we approach it and on the business requirements. Again, one of the simplest way, if we are feeling very comfortable and strong in our analytical and forensics capabilities, we can just remove the offending files or remove the malware. So it can help. Again, as a security professional, you will be facing this decision on day-to-day basis. Depends on your incline in the security field, but that's a couple decisions that needs to be made during eradication process. Recovery. Recovery process is pretty much we're going back to business, and what really does it mean? So we know that system is clean, there is no malware, and it's fully functioning and providing services to our customers. So again, we did our due diligence, we found malware, we removed it, but it's always a great practice actually to look into the system that we remediated and make sure that there is no other entry vectors, or we might miss something. So we need to closely monitor the system and data flows from the system or to the system in order to understand if we miss something. And of course, that's might sound a little bit, why do we need a lesson learned? Actually, lesson learned is a great activity. First of all, we not only recreating this incident and event, we have an opportunity to document it, to update our procedures, to update maybe our people skills, such as we had a hard time, or it took us long to, I don't know, reconfigure the firewall. So we might need to be able to train someone in order to make it more efficient. Then we might say, oh, you know what, we have exactly same server on the network. We better patch it or do whatever we did in order to remediate the issue. So, and again, like from a technical perspective, that's the main point what we're doing. But also, it's very important to show our managers, bosses, or whomever that we are actually continuously improving in our services. That's why I'm saying incident will happen, but security team will be as efficient as they actually try to be proactive on preventing incidents from happening. And basically incident response, specifically lesson learned part, will show if we are reusing our knowledge to pretty much help with it. Okay, so Jared kindly put together a real-world example from his practice. Jared, do you want to present? And I'll just flip slides for you.
Yeah, sure. Sounds good. Thanks, Alexi. So like Alexi said, the incident response process is something that in the security industry, you, as a security professional, you live and breathe kind of every day. And it's, you know, for each incident you're dealing with, you're doing the same process. And again, it's a circular cycle of improvement, effectively. So I just wanted to bring you through sort of, it might seem like kind of a trivial example, but something that happened in the real world. And Alexi, sorry, I can't actually see the right slides for some reason. I'm looking at the wrong one, but if you can just go to slide 14, IR in practice. Okay, so here's the scenario. I work with schools, universities for my day job, and a university called me up and said, hey, we think something weird is going on with one of our servers because our network person thinks there's too much traffic coming from this server, but it's Linux, and some guy set this server up a long time ago and he doesn't work here anymore, so we don't know what's going on. Can you go to the preparation slide? So this wasn't my server, so I had zero opportunity to do any preparation whatsoever. And because this server was put in place without a lot of knowledge about it, there was very little prep done. So the university calls me and says, help. So now we're into slide 16. We're actually kind of a part of the identification phase right now. They don't know what's wrong. They only sort of saw the tip of the iceberg. It was an indication of something. So I hop on the server and just say, you know, who's here? So there's me, and there's someone logged in from Gaza, which is generally, you know, not expected. On the far left it says root. That means that that's the super user. You can do anything you want on this machine. So we've identified that we have a problem.
So can I just interrupt here, Jared? Sorry, some of us are not able to see the slide.
Okay, Alexi, are we on slide 17? Title identification.
Let me just stop presenting and I'll start it again and we'll see if it helps. Please let me know.
Sure.
I completely lost. Just bear with me. I guess I have a problem with my browser. That doesn't help a lot. And was it the same for the slides that I was going through?
I was only able to see slide IR phase 3 containment.
That's quite interesting.
Alessi, do you want me to try and present?
Let me just try. Let me give it another try.
Yeah.
And we'll go from there.
Firewall.
Okay, can everybody see the slide Canadian Cyber Defense Challenge Session 2?
No, I cannot.
I cannot see it.
I cannot see it either.
Okay, Jared, I'll give you a presenter's right. How did I do that?
Yeah, I already have it.
Okay, perfect. So
let me see what I can do here.
Yeah, I'll just stop my presentation.
Okay, can you guys see my desktop now?
I can see a black screen, so I don't see anything on your desktop.
Okay, let me just hang up and dial in again. Sorry for the inconveniences. I think I could try to.
Yeah, it says I'm presenting, so I'm not sure what else I can do.
Did you want to send them to me and see if I can present?
Yeah, I'll send you the link, Greg.
Okay, we can see Oli's screen. Oh, it just went away.
The link should be in your inbox, Greg.
Yep, I've got it. I'm just trying to present here too, so.
Okay. Okay, Greg, I'm just going to carry on just in the interest of time. If you can get it up, that's awesome. We're at slide 17.
Sure, I'm not having any success presenting my desktop here, so.
Good to know it's not just me. Okay. Okay, so we're at the identification stage here. So we know we're not alone. We don't know how they got in. We don't know what they've changed. So we start looking around. log files are a really great place to look, and because this is primarily a web server and we know that it's essentially flapping out in the wind on the internet, the first place we look is in the web server log files. We didn't have to look very far to find an entry that essentially shows that there's a bug in the, well, it's called phpMyAdmin, but it's a database GUI that for administrators, essentially. Nobody knew it was there. It was super old, and it was super full of holes, and it was wide open to the internet. So in the web server log files, we're able to see that the attacker was able to convince the web server to go download his or her malicious payload off of this server in Gaza. So that's fantastic. He got the web server to do his bidding, and he carried on from there. Once he was in, he got the web server to do more stuff for him, including cracking the root password. Lucky for him, SSH was already open to the world, so all he had to do was saunter right in, log in his root, and the machine's his. Fantastic. So what we discovered after that, they didn't do a really good job hiding their files, so we were actually able to... oh, fantastic. Can we go to slide 18, please, Greg? We were able to just look and see what the payload was doing. So essentially, it joined a worldwide botnet and waited for a command and control channel to open just to tell this machine what to do. What it was actually doing was trying to hack voice systems with a nasty tool called SipVicious. SipVicious is really, really, really loud because it just sprays all over the internet looking for SIP servers or telephony servers to attack, and that was actually what was causing the high traffic. So fantastic. We know how they got in, we know what they're doing, and we know from where. Okay, next slide, please. So we need to contain this thing. We've identified what the problem is. We need to contain this thing. So a reasonable person would just say, well, just shut the machine off. Like, obviously, right? Well, the problem is that machine's doing some really important stuff. It was a learning management system, and students were actively taking courses on it, and it was leading right up to some important time in the year. And they said, under no circumstance is this machine to go away. So what are we as IT professionals to do? That's not our decision to make whether or not to pull it off the wire. That's really a business decision. So the best thing we can really do is do the best we can at containing this thing and making sure that no further damage happens. So what we did in practice is we just firewalled the thing like crazy, and we restricted communications just to Canadian IP addresses. That was enough to keep the attacker out. And we also dumped the host memory and file systems for later forensic analysis. Okay, next slide. So eradication, we were lucky. They didn't mess with user data. They could have deleted the database and we would have been in a world of hurt. But all they wanted to do was actually use the host for attacking. So we were actually able to verify that none of the file system had been modified apart from where they put their dropper. So we took the files out, we removed phpMyAdmin, we patched the host, and we were pretty confident that we got rid of the problem. Next slide. In terms of recovery, this was actually kind of hilarious because the attacker tried to come back repeatedly and aggressively. We were able to heavily monitor the host, including like the file systems, the networks, traffics, application. But the attacker was really persistent, but they weren't able to get back in, principally because we were blocking IPs that weren't Canadian from coming in. There were lots of lessons learned here. Oh, sorry, what slide are we on? Sorry, I have a duplicate slide. We can go to the next slide, Greg. So the lessons learned were lots. This host was poorly managed, but we ended up putting a whole bunch of controls on, including firewall rules, patching, obviously. SE Linux, which is Security Enhanced Linux, which is a way of preventing a web server from running arbitrary commands, for example. We also have regular file system integrity checks to make sure nothing gets changed on the host without our knowledge. We put it on a web app firewall, which is just a fancy firewall. And we regularly do vulnerability assessments. So we point tools, such as Nmap, to make sure that the ports that are open are the ports that we want to have open. So there we go. That's an example of, this wasn't a big incident, but it was a problem. So that's the process, sort of by example. I know we're really tight on time here, but slide 24, resources. I just wanted to point you to a few things that we're going to be using in upcoming seminars. There's a couple of cheat sheets from the SANS Center that you should probably check out. And also on the next slide, there are 3 things that I would like if you're going to participate in the further seminars. We're going to be covering Wireshark, which is a packet analysis tool. We're going to be looking at Nmap or ZenMap, whichever, depending on what platform you have. ZenMap is sort of a graphical user interface. So this is a reconnaissance tool. It's a port scanner, sort of on steroids. And I'd also like you to look at Test Disk. Test Disk is a kind of a cool tool. It's usually used to try and undelete files on file systems, or explore unknown file systems. It's very useful for looking at like a forensic image of like a USB stick or something like that. So so any students who want to participate down the road, I'd encourage you to check out these 3 tools. We'll be talking about them heavily, and they'll very likely play heavily into the CDC competition on the 10th of May. That's all I have. Can I open it up to any questions that anybody might have for either me or Alexi?
Yeah, sorry, I have quite a bad.
Okay, it doesn't look like there's any questions. So on behalf of everyone, I'd like to thank you, Jared and Alexi, for presenting today. Our next session will be March 22nd. So I will be sending out an email invite once again, so you can join using Skype for Business. Yeah, I think this was awesome, and like I said, I hope we can keep building some momentum heading into May 10th.
Excellent. And just one more thing regarding those 3 tools I mentioned. Our intention is to have it be hands-on, so if you'd like to participate, we're going to have some workshop-y kind of things. They won't be long, but we'd like for the students to be familiar with the tools. So if you have a machine to bring with you, that would be awesome.
Awesome. Yes, so I am recording this. I will save it, and I'll try to get it out to everyone who was unable to attend or had some problems, technical issues. Before we go, there's one question here. Can I have 2 instances of the call open next time? We'd have to give it a test. Just make sure that you have a microphone attached to whatever device. For some reason, Skype for Business does not like it when you don't have a microphone and speakers attached as well. If you have any questions, Jared, Alexi, will the document or presentation be available?
Yes, the QR code or that short URL should be visible to the students, I believe. Is that shared, Alexi?
Again, I'm sharing whatever I can. My problem right now, I cannot hear. Our connection is super poor. I guess due to a lack of quality of service on our network right now that I'm on. So I hope that you are able to hear me and see the first slide. It has a shortened link, so feel free to use it.
Yeah, and Greg, the link that I sent to you should be a publicly shareable link as well. So
perfect.
Yeah.
Then I will share that out.
You can circulate that for sure.
Okay. Thank you, guys, and we'll sign off.
Okay. Thank you for your time, everyone.
Thank you, everybody.